Hey everyone and welcome to the channel. Today we are diving into a crucial concept in Apache Spark that can significantly optimize your cluster resource utilization: dynamic allocation. If you ever wondered how Spark efficiently manages its executors based on workloads, you are in the right place. Let's get started. Before we talk about dynamic allocation, it's important to understand the traditional approach: static allocation. In a statically allocated Spark cluster, when you launch an application, you request a specific number of executors. These executors are then reserved for your application for its entire duration, regardless of the actual workload. The problem here is that during periods of low activity, these executors sit idle, consuming valuable cluster resources that could be used by other applications. This can lead to inefficient resource utilization and potentially higher costs. This is where dynamic allocation comes to the rescue. Instead of a fixed number of executors, dynamic allocation allows Spark to request and release executors as needed during the application's runtime. When your application has a lot of work to do, Spark can scale up by requesting more executors. Conversely, when the workload decreases and executors become idle, Spark can scale down by releasing those executors back to the cluster. This on-demand scaling leads to much better resource utilization. So how does Spark achieve this dynamic scaling? It relies on a few key components. The Spark context continuously monitors the workload of your application. Based on pending tasks and the utilization of existing executors, it can request more executors from the cluster manager. When executors become idle for a certain period, the Spark context can also decide to release them. A crucial part of this process is the external shuffle service. When executors are deallocated, any shuffle data they might hold needs to be preserved for subsequent stages. The external shuffle service running on each worker node takes care of this, ensuring that data isn't lost when executors are removed. To control dynamic allocation, Spark provides several important configuration parameters. The most fundamental is spark.dynamicallocation.enabled, which you need to set to true to activate the feature. You can also define the spark.dynamicallocation.main executors, which sets the minimum number of executors that will always be running, and spark.dynamicallocation.max executors, which limits the maximum number of executors that can be requested. The spark.dynamicallocation.executor idle timeout setting determines how long an executor must be idle before it becomes a candidate for removal. Finally, remember that the spark.shuffle.service.enabled property must be set to true for dynamic allocation to work correctly. Also, along with this, we need to specify the spark.shuffle.service.port. So, what are the key advantages of using dynamic allocation? Firstly, it leads to better resource efficiency by only using the resources you actually need. This can translate to significant cost savings, especially in cloud environments where you pay for the resources you consume. By freeing up idle executors, dynamic allocation also leads to improved overall cluster utilization, allowing other applications to run more efficiently. Finally, it can lead to better performance for concurrent applications running on the same cluster as the resources are distributed more effectively. While dynamic allocation offers many benefits, there are a few things to keep in mind. There is a slight overhead associated with acquiring and releasing executors. So, for very short-lived jobs, the benefits might be less pronounced. It's crucial to tune the configuration parameters appropriately for your specific workload and cluster environment. Also, it's important to monitor the dynamic allocation behavior to ensure it's working as expected and making adjustments if needed. Dynamic allocation is a powerful tool in Spark for optimizing resource utilization and cost efficiency. By understanding how it works and configuring it correctly, you can significantly improve the performance and management of your Spark applications. If you found this video helpful, please like and subscribe for more Spark tutorials. Let me know in the comments if you have any questions or specific topics you'd like me to cover in the future. Thanks for watching.